Hello and welcome to Calsoft's podcast series. My name is Umang and I will be your host for this podcast. Today we have Mr. Sachin Mali with us, who is a veteran technologist, and we will be discussing about Erasure coding. Hello Sachin, it's pleasure to have you with us. So Sachin is a senior QA lead at Calsoft. He has 13 plus years of experience in the IT industry and his major experience is in storage and virtualization technology. NFS protocol and virtualization are his strengths. Today Sachin will be talking about Erasure coding. He will elaborate more detail about it. So without any further delay, let's quickly start the discussion. So Sachin, what is Erasure coding?
Sure, Umang. But before moving to Erasure coding, everybody has to understand what is distributed storage and what is RAID. I will give a brief about RAID and distributed storage, then I will jump into Erasure coding. Is it okay?
Yeah, sure.
Basically, distributed storage means your data is distributed across some geographical location. Geographical location could be in array, could be in a different host, could be across the globe. Data can be accessible through several different mediums, but integrity of storage counted it as one unit. So your storage is distributed and entire unit counted as one. Hope this clear about distributed storage. For more detail, audience can visit my earlier podcast on distributed file systems. And now we can see RAID. RAID means redundant array of inexpensive disk, or we can call as redundant array of independent disks. This technology is used to give bigger size of storage to user. Also, there are a lot of benefits available of this method, or you can say technology. For example, data availability after disk failure. RAID is also useful to improve I/O performance. We can also say that RAID is a special form of Erasure code. In RAID, data is distributed across the drive. Data distribution is depend on the RAID level. Based off the performance or data security, user will choose the RAID level. The ultimate goal of RAID level is reliability, availability, performance, and capacity. RAID levels are differentiated with the numbers just like 0, 1, 4, 5, 10, or 0, 1. Few of the RAID level employ an error scheme called as parity. This method is widely used in IT to provide fault tolerance. To calculate RAID parity, ZOR algorithm is getting used. Now we will look into erasure coding. Erasure coding is a method of data protection. It is not a part of RAID. We can say it is a substitute or alternative for RAID. In erasure code, data is encoded and distributed across the storage media or location. Erasure code is also known as FEC. It means forward error correction. Essentially, the idea to adopt this kind of solution is for a drive failure or spinning media failure. In today's world, the capacity is rapidly increasing and we are storing hundreds of thousands of petabytes of data. And if any drive failure happens in RAID environment, then it will take days to rebuild the data. With that, you can easily argument that RAID is of its end of usefulness in most of the environment. Same thing happened with the tape drive. It became obsolete from the industry. Usually, erasure code got used most of these cases instead of traditional RAID. It has lot of advantage with a drawback of CPU intensiveness. Reed-Solomon algorithm, which is used in erasure coding for reconstructing the data, but it takes a lot of CPU cycle. Thanks over.
Thanks Sachin. But now I am more interested to understand how Erasure coding work or how it stores data.
Sure, it's very good question, Suma. Nowadays, we are storing vast amount of data, and major concern point is data corruption or data protection scheme. In industry, most commonly used data protection scheme is either replication or erasure code. Like replication, erasure code write data across multiple disks on multiple servers, which allow data to survive in multiple disk failure conditions. Unlike RAID or EXIT, erasure code calculate parity to protect a large amount of data. However, number of parity ratio is much higher in case of erasure code. Today's commodity processors like GPU are allowing erasure code to calculate parity in much higher speed. For parity calculation, Reed-Solomon algorithm is getting used in erasure code. In my opinion, as an engineer, everybody should understand the complete data flow. So, to understand erasure code, first we have to understand mathematical equation which erasure code uses for reconstructing the data. Let's consider equation is just like n equals to k plus m. So in this condition, we can consider n is a total number of drive, k is a total number of data drive, m is a total number of parity drives. So in example, we can say 5 equals to 4 plus 2. So in above example, erasure code can support 2 drive failure. So drive failure is totally depend on the disks user has chosen. User can choose the number of drive for data and parity based on the critical of data. Now we can have a look on how erasure code works. Through an example, we will try to understand how erasure code works. Suppose you have 5 total drive and you have decided to choose 3 drive for data and 2 drive for parity. So whenever the data write request come, that time data will be stripped among 5 drive. Out of that, 3 drive will be for data writes, 2 will be for parity. Most common algorithm is getting used for parity and that is Reed-Solomon algorithm. In erasure code, large amount of data can be reconstructed. Let's explore. Erasure code with an example of set drive size 12 and parity drive size 4. In this condition, we will make 12 separate writes, 8 data write and 4 parity write. Any 4 write can fail. Original data can be reconstructed with this advanced level of protection. It can take only 50% more storage. For example, to store 10 MB of file, you will require 15 MB of space. We can also increase the level of availability by increasing the ratio of parity to data.
Thanks, Sachin. By now, I got the glimpse of Erasure code and how it works. There might be some upside and downside of this data storing method. So, can you put some light on it?
Yes, Umang. There are upsides and downsides of this method. First, we will look at the upside of this method. Method means erasure code. So, in upside, data security is first one. So, fault tolerance is coming under data security. It means support of number of simultaneous failure without a loss of data. In replication technology, data is multiplied with identical copies across multiple sites. But in erasure code, data blocks or objects are stored and distributed across multiple storage nodes with encoding, which give more reliability or security to data. If we compare replication and erasure coding, then erasure code would be more effective. Second upside is data availability. Data availability means who can provide faster access of data when failure occurs. In compared with replication, erasure code will rebuild, and provide faster access to data in case of data failure. Third upside is storage efficiency. Erasure code has much higher rate of data efficiency by comparing with replication. Replication will require exact double amount of storage space. So these are we have looked it into the upside of erasure. Now we can just have a downside of the things. There are not much downside of the erasure code. It is only two. First is like the parity calculation is CPU intensive. It means while parity calculation is happening, so that time CPU is getting used as their peak. Second, increased latency can slow the production write in rebuild process.
Thank you, Sachin, for explaining upside and downside of Erasure coding. Now, after understanding Erasure code, I feel RAID and Erasure code are same, isn't it?
No, RAID and erasure code are two different methods of data protection. This both technology or method get used for data protection, but both are different and each one has their own pros and cons. If you take RAID 5 for data protection, then you will get support for only one drive failure. And if you take RAID 6, then you will get support for two drive failure. But in case of erasure code, it is totally depend on the scheme which user has chosen for data protection. Data protection scheme means the combination of data drive and priority drive from total available drives. RAID is getting used for to store data in a different location and it allow or support only for few drive failure. In case of erasure code, reads the data in part and store it with encoded value on a different or multiple location. Also, it consumes less storage space than RAID.
So now we understand difference between Erasure code and RAID, but in real world, where can enterprises uses Erasure coding?
So, enterprise that requires a failure-free storage environment need to incorporate erasure coding technology. Here are some instances where erasure code can be very beneficial, just like disk array systems, data grid systems, distributed storage application, object store, archival data store. So these are the methods or these are the beneficial areas where erasure code can be more beneficial. Common use cases or example is cloud. In general industry, is using cloud storage to store archival data and their data latency can be tolerated. In that case, EC will be the best fit. But in case where data is stored for bank transactions, their latency is one of the prime concern. Their erasure code will not be the best fit. Thank you, Umang. So this is the short and brief about erasure code. Hope the user get a glimpse of what exactly the erasure code it is. Thank you very much, Umang, for giving me the opportunity of this talk.
Thanks, Sachin. It was very insightful session on Erasure coding and how it works and stores data. We learned upside and downside of this method and also got to know the difference between Erasure code and RAID. So thanks listener for tuning in. Please write to us at marketing@calsoftinc.com for any queries and stay tuned for our future podcast. Thanks, Sachin.
Thank you, Umang.